Hello everyone, I am Dr. G. Bharati from Physics Department of Comrade College of Engineering and Technology. Discuss about the optical fiber, its basics, types and applications. So this is the outline of my presentation. First we will go to discuss about the introduction about optical fiber and types of optical fiber. Finally, I wish to discuss about the applications of optical fiber. So basically this is the structure of the optical fiber. So the optical fiber is having the very important parts of the optical fiber are core and cladding. So both of them are made up of similar material like silicon dioxide. If it is a glass fiber, it is made up of silicon dioxide, core and cladding also, but they are having slight refractive index difference between this core and cladding. So core is a basic one and next outer layer is cladding and there are some coating. This is to protect the optical fiber, and finally there is a strengthening member. It is Kelvar is used as a strengthening member here. Finally there is a polyurethane jacket to protect the optical fiber efficiently. So this is the basic structure of the optical fiber. So what is the principle behind the optical fiber? So total internal reflection, this is a basic principle behind the optical fiber. So normally if a light moving from a medium to another medium, half of the light get reflected and half of it get transmitted. Here we have to avoid the transmission, only we need reflection. So it can be achieved by total internal reflection. To achieve the total internal reflection condition, the light must satisfy two conditions. The incident ray must satisfy two conditions. Initially the first condition is the light must travel from denser medium to rarer medium, and the second condition is the angle of incidence must be greater than the critical angle. So these are the two conditions to achieve total internal reflection in optical fiber. To achieve the first condition, let us see here, let us assume that the refractive index of the core is N1 and the refractive index of the cladding is N2. Here core is a denser medium and cladding is a rarer medium. So N1 must be greater than N2. So the first condition gets satisfied. Here the light can travel from denser medium to rarer medium. And the second condition is the angle of incidence. The angle of incidence must be greater than the critical angle. If both the conditions are satisfied, now the light get total internal reflected within the optical fiber core. So if the condition is not satisfied, the light cannot get total internal reflection. There are some part of dispersions can occur. And one more angle we must know, that is the acceptance angle. This is the angle at or below which the light can suffer total internal reflection, that is called acceptance angle. And when the light enter through this particular cone, it is called acceptance cone. So within this cone, if the light enter through the optical fiber, it gets total internal reflected. So after that they cannot achieve this condition and they didn't achieve the total internal reflection condition. So the angle at or below which the light can suffer total internal reflection is called acceptance angle. So these are the basic aspects of the optical fiber. Now we will discuss the types of optical fiber. The optical fibers are classified into three categories based on the material used and based on their refractive index profile and based on the mode of light propagation. First we will discuss one by one. First, mode of light propagation. It can be split up into single mode fiber and multi-mode fiber. So the difference between these two is it can able to transmit only one signal at a time, and multi-mode fiber can transmit many signals at a time. And based on the material used, it can be classified into glass fiber and plastic fiber. So these glass fibers are made up of glass materials and plastic fibers are made up of plastic materials, and based on the refractive index profile they are classified into step index fiber and graded index fiber. So we will see one by one. So first one is based on the modes of propagation. So it can be split up into single mode fiber and multi-mode fiber. The name itself indicates single mode, multi-mode. So what is the difference between these single mode and multi-mode fiber? In the single mode fiber, it can able to transmit only one signal at a time. So its core diameter is very less, it is around 9 micrometer. It is a very smaller core diameter and the cladding diameter is greater. But in the case of multi-mode fiber, this core diameter is greater, it is around nearly 50 to 62.5 micrometer. So it can able to transmit many signals at a time. So these multi-mode fibers are normally used for commercial purpose, and these single mode fibers are mainly used for long haul communication to send the signal secretly, efficiently for a long distance. We can use this single mode fiber. So single mode fiber, about single mode fiber, here only one path is available. We can transmit only one signal at a time, and its core diameter is very small, and here this, because of this core diameter is very small, there is no dispersion at all. So it is having higher bandwidth. One of its advantages, it is having higher bandwidth around 1000 megahertz, and it is used for long haul communication, and it is, but its fabrication is somewhat difficult because its core diameter is very less. So the construction is somewhat difficult in this case of single mode fiber. In the case of multi-mode fiber, we can send many signals at a time, that is more than one path is available, but this core diameter is higher. So it is allowed many signals, so dispersion ratio is also greater, higher dispersion, but it is having lower bandwidth. So in case of single mode fiber, it is having higher bandwidth, but in the case of multi-mode fiber, it is having lower bandwidth, it is around 50 megahertz, and it cannot be used for long haul communication, only it is used for short distance communication, and its fabrication is not that much difficult because its core diameter is greater. So it is not difficult to make it for the fabrication. Okay. So the next category is based on the material used. Based on the material used, the optical fibers are classified into two categories. One is glass fiber and the second one is plastic fiber. So first one is glass fiber. So it is a mixture of either metal oxide and silica glasses. Okay. So silica, it's have a refractive index around 1.458. Okay. So but we must have to achieve total internal reflection, the light must travel from denser medium to rarer medium. So now the core refractive index of the core must be greater than the refractive index of the cladding. So for both core and cladding, we are using the same material, that is silicon dioxide. The same material is used. To vary the refractive index, some impurities are added or doped with the silicon dioxide. So these are the some of the dopant materials such as boric oxide, germanium dioxide or phosphorus dioxide can be added to decrease the refractive index of the cladding. So now the core refractive index of the core is greater and the refractive index of the cladding is less. So here one of the example is silicon dioxide. Here silicon dioxide is used as the core and the combination of some dopant is added with the silicon dioxide to make the cladding. So this is the glass fiber. So it is basically made up of glass materials like silicon dioxide. Next one is plastic fiber. It is made up of some plastic material. It's mainly used for commercial purpose. So it is durability is greater and it is flexible to all extent. So greater signal attenuation than the glass fibers, it is greater toughness, durability, these are all the advantages of this plastic fiber. So the refractive index difference between the core and the cladding material is very high. So these plastic fibers have high numerical aperture and larger angle of acceptance, acceptance angle it is having. So, these are all the advantages of these plastic fibers. We can use it for commercial purpose, we can bend it to any extent, there is no problem with it. So, some of the examples of this plastic fiber is, a core material is polymethyl methacrylate and its copolymer is used as the gladding. So, there are many examples for this plastic fiber. So, plastic fibers have some advantages. What are the advantages of it? So, it is having greater signal attenuation, it is having higher durability, similarly they are having higher toughness and it is having large acceptance angle also. These are the advantages of plastic fiber. And the third category is based on the refractive index profile. So, based on the refractive index profile, they are split up into step index fiber and graded index fiber. So, step index fiber we will discuss one by one. So, this one is the step index fiber. In step index fiber there are two categories, two types. One is single mode step index fiber and the next one is multi-mode step index fiber. So, already we discussed about the single mode and multi-mode fiber. So, these two kinds are available in the step index fiber. Here the main difference between step index and graded index fiber is, here the refractive index varies step by step. So, here the refractive index of the core is N1 and the refractive index of the gladding is N2 and for air it is N0. So, it varies step by step. So, it is called step index fiber. So, there are two types of step index fibers are available. One is single mode step index fiber and other one is multi mode step index fiber. In case of single mode step index fiber, this core diameter is very less, it can allow only one mode of propagation, fabrication is somewhat difficult. But in the case of multi mode fiber, here it can allow many signals at a time and its core diameter is larger and its fabrication is not that much difficult. And the next category is graded index fiber. So, here within the core its refractive index vary layer by layer. So, nearer to the core the refractive index is maximum and if it approaches nearer the gladding surface, its refractive index becomes minimum. If we divide it into many segments, consider here it is Na. Here the refractive index is Na and next layer Nb, Nc and Nd. Here this Na is greater than Nb, Nb is greater than Nc and Nc is greater than Nd. So, when it approaches the gladding, its refractive index gradually decreases. So, it is called graded index fiber. So, it will allow the light, it transmit the light efficiently through the optical fiber. So, these are all the different types of optical fiber. So, first we will recall it. First, based on the mode, it can be divided into single mode and multi mode. The difference between the single mode and multi mode fiber is, single mode fiber can able to transmit only one signal at a time, multi-mode fiber can transmit many signals at a time, and based on the material used they are classified into two categories. One is glass fiber and other one is plastic fiber. Glass fiber is made up of glass materials like silicon dioxide and it is doped with some other material to form the gladding. And plastic fibers are made up of some plastic materials like polymethyl methacrylate. It can be added its gladding material is some copolymers of it, but these plastic fibers have some advantages like high durability and it can bend to any extent. So, these are all the benefits of the plastic fiber. And the next category is based on the refractive index profile, they can be split up into step index fiber and graded index fiber. In the case of step index fiber, the refractive index varies step by step. So, there are two types of step index fiber. One is single mode step index fiber and other one is multi mode step index fiber, and the final one is graded index fiber. Here within the core the refractive index varies layer by layer. So, it is gradually increases when it approaches the core and it is gradually decreases when it approaches the gladding. That is a basic difference. So, light can efficiently send through this optical fiber. So, these are the different types of optical fiber. Next we will discuss about the applications of optical fiber. So, here I am going to discuss about one of the application of the optical fiber, that is fiber optic sensors. So, these optical fiber sensors are classified into intrinsic sensor and extrinsic sensor. So, the difference between these two is, first one, intrinsic sensor. These intrinsic sensors are, here optical fibers are used as the sensing element in intrinsic sensor. So, the physical quantity like temperature or pressure can be measured. It causes some changes in the fiber itself, and this type of sensors are called intrinsic sensor. So, what are the modulated light parameters? Where if it is a sensing area, it is a particular testing environment, if we put the optical fiber here, the light transmission get affected because of the physical parameter around it. Okay. So, the modulated light parameters here are intensity, its phase, its polarization, wavelength and transit time. And extrinsic sensor, these sensors are, we are using two optical fibers. One fiber is it is used as an input fiber and other one is output fiber. So, it is just used as a guiding media. So, it is used as a guiding media. This fiber optic cable used to guide the light from a conventional sensor. So, it is used to measure either vibration, rotation, displacement, velocity, acceleration and torque. So, all these kinds of physical parameters we can measure using this extrinsic sensor. So, we will discuss these intrinsic and extrinsic sensors one by one. Now, we discuss about intrinsic sensor. So, it can able to measure either temperature, pressure and different physical parameters using this type of sensors. Here we are going to discuss about temperature sensor. So, this is a basic construction of a intrinsic sensor. There are different parts, laser source, there is a beam splitter and 3 lenses, L1, L2, L3 or 3 lenses, and there are 2 fibers, one is testing fiber and other one is reference fiber. So, the difference between intrinsic and extrinsic sensors are that testing fiber will be in that particular measuring environment. So, it will get affected by that particular physical parameter, and finally, we will merge these two rays and to measure the temperature at that particular environment. So, initially this is a laser source, it can able to produce the laser, and there is a beam splitter. This 45-degree inclined glass plate, that is a beam splitter, splits the ray into 2. So, one is sent through the lens L1 and the other is reflected and it is passed through lens L3. So, one part of the light is sent to the testing fiber and other part of the light is sent to the reference fiber. So, if effectively the lens is used to focus that particular laser source into that particular fibers. So, through reference fiber this light is not affected by any environment. So, it is just used for reference purpose, and this is a measuring environment. So, within that how much temperature is there. So, you have to measure the temperature within that measuring environment. Now, the testing fiber is kept within that particular measuring environment. So, now the light, half of the light is sent through this testing fiber, it will get affected by this particular environment and there are some changes in the output light, whether its phase or polarization, any one of the parameters get changed because of this measuring environment, because of this temperature, or we can measure pressure also. So, because of pressure in this optical fiber there is some micro level bendings are there. So, it will affect the light. So, effectively both the lights are focused by the similar lens and it will get submerged with each other, and finally it forms a interference pattern. So, by analyzing the interference pattern we can able to measure the temperature at that particular environment. So, two lights are superimposed with each other, they form the interference pattern. So, by analyzing this interference pattern effectively we can find the temperature at that particular environment. So, this type of sensor is known as temperature sensor. So, similarly we can measure the pressure also. So, many parameters we can measure. So, these types of sensors are called intrinsic sensor. Intrinsic sensor means the fiber is tested, it is kept within that particular environment. That type of fibers is called intrinsic sensors. So, the next type of sensors is called extrinsic sensors. So, we can measure the acceleration, velocity, displacement, any type of physical parameters using this extrinsic sensor. Here the part of the optical fiber is only to guide the light effectively. So, it is just used as a guiding media. So, here also there are two types of fibers used, one is the transmitting fiber, another one is the receiving fiber. Here the laser source is this, here the sensor is a displacement sensor, this is the object. So, I have to measure the displacement of this object by using this sensor. So, initially there is a laser source and there is one detector and two fibers, one is transmitting fiber and other one is receiving fiber. Now, the signals laser light is sent through the transmitting fiber, it will be total internal reflected and it falls on the moving object, and from that the reflected light from the moving target will be received by this receiving fiber and it will effectively totally internally reflected and again it will comes to the detector. So, the signals are sent through the transmitting fiber and the signals are received by using this receiving fiber. These signals are detected. So, if the target is approaching towards the sensor, its intensity is greater, intensity of the light is greater. If it is moving far away from the sensor, then the intensity of the light is less. So, by analyzing these factors, we can able to find the displacement of that particular object. So, these are all the different types of sensors, that is one is intrinsic sensor and the second one is displacement sensor. We will discuss the other topics in my next video. Thank you.